Today's lesson is trigonometric functions of angles. What is my learning objective today? I can determine the sine, cosine, and tangent of an angle with the terminal side of an angle given by the coordinates by applying combining knowledge of sine, cosine, and tangent with the coordinate plane. I can determine whether sine, cosine, or tangent of an angle is positive, negative, or zero without a calculator by combining knowledge of sine, cosine, and tangent with the coordinate plane. So what's the mnemonic that we use to remember our trig, sine, cosine, and tangent? Is SOHCAHTOA. SOHCAHTOA. And this helps me remember that sine is the opposite leg over the hypotenuse, cosine is the adjacent leg over the hypotenuse, and tangent is the opposite leg over the adjacent leg. All right. So sine is opposite. Sine is opposite over hypotenuse. So if I drew a triangle in the first quadrant here, my right angle is always going to be perpendicular to the x-axis, and theta is the angle that I'm talking about. So the horizontal distance on the coordinate plane is x, the vertical distance is y, and to my point xy, this is my radius. So on the coordinate plane, sine is going to be opposite the angle, a reference angle, so that's going to be y, divided by the hypotenuse, which is r, the radius. Let's do the same thing for cosine. So cosine is adjacent divided by hypotenuse. So the adjacent side, or the adjacent leg, is x. The hypotenuse is r. Tangent is going to be opposite divided by adjacent. So opposite is my y divided by adjacent, which is x. Okay, so we're just taking, instead of using the words opposite, adjacent, and hypotenuse, I'm thinking the words, but I'm writing x, y, or r for radius, and we're getting that from a circle. So we're really thinking about the Pythagorean theorem, which is leg squared plus leg squared equals the hypotenuse squared. I'm doing that, but I'm using the equation of a circle with the vertex on the center as x squared plus y squared equals my radius squared. And we learned this in geometry. So what do I want to do? I always want to draw the triangle and then label the reference angle first. So the reference angle, again, is an acute angle from the terminal side to the x-axis. And the right angle is always on the x-axis. So the right angle is always on the x-axis. The reference angle is always near the origin. And when I'm talking about a radius of a circle, a radius is always positive. So x and y can be positive and negative. Now, so the legs, so I'm talking about the Pythagorean theorem where the legs can be positive or negative, but the radius is always positive. Okay, so let's do some examples. Find the coordinates of a point on the terminal side of an angle. Find the values of sine, cosine, and tangent. So I'm really just looking at this and plotting my points, x and y. So the first thing I'm thinking about is what quadrant am I in? Since I'm both positive, I know and I'm just sketching this, so I know I'm in the first quadrant. So I want to draw my triangle in. So my right angle is always perpendicular to the x-axis, and my reference angle is always by the origin. And I'm going to start labeling. So here's x is horizontal, y is vertical, and the radius is here. So this is my point here, 6, 8. So x is 6 and y is 8. So this is asking me to find sine, cosine, and tangent. So in order to do that, I also need to solve for the radius. So I'm using the equation x squared plus y squared equals my radius squared. So x squared, and I would write these in parentheses because I'm going to start working with positive and negatives now because I'm on the coordinate plane. Plus y squared is 8 quantity squared equals my radius squared. So 36 plus 64 equals my radius squared. 100 equals my radius squared. Taking the square root, r is 10. So the radius is always positive. So now I can start substituting these into my equation for sine, cosine, and tangent. So sine is y. We said y is 8. My radius we just calculated is 10. So I always simplify fractions. So sine is 4 divided by 5. Cosine is x, which is 6. My radius is 10. Simplified, this is 3 over 5. Tangent is y divided by x. So 8 divided by 6 is 4 over 3. Okay, I'm going to have you try the next one. I will pause this and then come back and check your answers. So I am going to start out with, I know that this is my x value, this is my y value. I know I'm in the fourth quadrant because x is positive and y is negative. So I'm just drawing a triangle in the fourth quadrant. I'm sketching it. I don't really care if it's to scale or not. So I know my x value is 3. My y value is -1. Here is my reference angle. This is the terminal side, so this is 3, -1. So I need to calculate my radius. So my radius is x squared plus y squared equals my radius squared. So x is 3 quantity squared plus y is -1 quantity squared equals r squared. So 9 plus 1 equals r squared. So 10 equals r squared. So my radius is the square root of 10. I cannot simplify that anymore, so I stop there. So now I'm just substituting. I have x, y, and r. Make sure you use the signs. So y is -1 divided by the square root of 10. I need to rationalize the denominator. So the denominator, I am going to multiply times 1 in the form of anything divided by itself. And I'm looking at the denominator. So the denominator is the square root of 10 over the square root of 10. So now I have two fractions. So I'm multiplying numerator times numerator and denominator times denominator. So -1 times the square root of 10 is negative square root of 10. Square root of 10 times the square root of 10 is 10. Substituting in for cosine is x divided by r. So x is 3. My radius is the square root of 10. Again, I need to rationalize my denominator. So I'm going to multiply by the square root of 10 divided by the square root of 10. So I have 3 times the square root of 10 over 10. And tangent is y over x. So y is -1 and x is 3. Okay, so just a reminder for working with radicals, I want to focus on that I know the square root of x times the square root of x always equals x. And the square root of x divided by the square root of x always equals 1. Anything divided by itself is 1. So I will use these two a lot with trig. All right, let's try number 3. If the cosine of theta is -2 divided by 7 and theta is in the second quadrant, find the value of sine of theta and tangent of theta. Okay, so I know I'm in the second quadrant, so I'm going to draw my triangle in. I know the right angle is always perpendicular to the x-axis. And my reference angle is near the origin. So I don't know what x and y are, but I do know in the second quadrant that I know x is negative and y is positive, and the radius is always positive. So cosine, by definition, is x divided by r. So I know the radius is going to be positive, so I know the negative sign has to go with the x value. So I know x is -2. My radius is 7. And this time I don't know the y value, so I'm doing the same process I did in the last two problems. I just have a different one of the 3 parts as the unknown, but I have the same process. So I'm going to start by finding what my y value is by using the equation x squared plus y squared equals my radius squared. So I know x is -2 quantity squared plus y squared equals 7 squared. So 4 equals y squared equals 49. I'm going to subtract 4 from both sides. This is plus. And I get y equals 45 and taking the square root. So this is the square root. Y squared is 45. So I'm going to take the square root of both sides. I know 45's perfect squares are 9 times 5. So I know y equals 3 times the square root of 5. So I'm going to substitute in. So I know y. The sine of theta is y divided by r. So y is 3 times the square root of 5 divided by my radius, which is 7. And tangent is y divided by x. So y is 3 times the square root of 5 divided by x, which is -2. Okay, so now I have to be paying attention to which quadrants are x and y positive and negative, and remember that the radius is always positive. All right, so let's kind of summarize this in a graphic organizer to help us remember what's going on here. So in the first quadrant, I know that x is positive and y is positive. In the fourth quadrant, I know x is positive. And I know in the second quadrant, y is positive. So each of my trig functions are positive in 2 quadrants and negative in 2 quadrants. So x is negative in the in the second and the third quadrants, and y is negative in the third and the fourth quadrants. So in the first quadrant, sine, cosine, and tangent are all positive. So everybody's positive in the first quadrant. In the second quadrant, sine is positive. In the third quadrant, tangent is positive. And in the fourth quadrant, cosine is positive. So everybody usually remembers this for first, second, third, and that doesn't look like a 3. Third and fourth. So most people remember this as this is for all 3, sine, tangent, and cosines. So all students take calculus. So students remember this acronym to help remember which quadrant everything is positive in. All right, next examples of what we're going to work on. So we're not using a calculator here. I want to just decide if the trig word is positive, negative, or 0. And we're doing that based on what we just said, that each trig function is positive in 2 quadrants and negative in 2 quadrants. If I'm on an axis, the x-axis or the y-axis, then I'm not positive or negative, so I'm 0. Okay, so if I'm taking a look here, a sine of 100, without typing this in the calculator, I know 100 degrees is in the second quadrant because it's more than 90 and less than 180. So I am saying to myself, all students take calculus. So S is for sine is positive. So I'm going to say sine of 100 degrees is positive. So same thing for cosine here. Cosine, this is 100 degrees. So this is all students take calculus. And I'm talking about cosine. So cosine is positive in the first and the fourth. So it is negative in the second quadrant. For 740 degrees, I'm going to find a coterminal angle that's in a single rotation. So I'm going to subtract out 360. And I get 380 degrees. I am still more than 360, so I'm going to subtract out another rotation. So I'm talking about 20 degrees. So that puts me in the first quadrant, and I know all trig functions are positive in the first quadrant. So cosine of 740 degrees is positive. Hey, let's try one in radians. So one circle is 12 pi radians. So I'm going to take out 2 pi radians. So I'm looking at the denominator, 2 pi radians. It's going to be twice as many as the denominator. So that's going to be 18 pi over 9 radians. 26 pi minus 18 pi is 8 pi over 9 radians. So setting this up halfway around is pi, and again, I'm looking at the denominator, so I'm changing it from 1 pi to 9 over 9, So that's placing me in the second quadrant. So I'm thinking this is tangent, so all students take calculus. So tangent is positive in the first and the third quadrant, so that makes it negative in the second quadrant. So this one is negative. Okay, I'm going to have you try 8 and 9. You tell me. So stop. Tell me if these are positive, negative, or 0. And then turn it back on after you check. So 240 degrees, here's 180, here's 270. So I know 240 is in the third quadrant. So all students take calculus. So I'm talking about tangent. So tangent is positive in the first and the third quadrant. So 240 degrees is positive. Negative 5 pi over 4. I'm going in the negative rotation. So I'm looking at the denominator here. So this is going to be negative 4 over 4. So if I'm going, this is 4. One more is going to be negative 5 over 4. So this puts me in the second quadrant. So tangent, all students take calculus. So tangent is positive in the first and the third quadrant. So it is negative in the second quadrant. Okay, that's it.